Just by getting too random.
Alright, let's see. Yeah, that's pretty much it. Oh yeah, that's it. That was the last thing. Okay. Here's that one last thing in 10.8.
Sweet.
One more thing. Recall. Now, this is something you know how to do. This is something you had to know how to do for the last test.
Yeah.
How do I do this?
Combine like terms?
No, well, okay, sure. Where are the like terms? No.
Oh. You got me there, Jeff.
No, well, there's only one fraction up here. There's only one fraction up here. So LCD doesn't make sense.
Multiply by the conjugate.
Multiply by the conjugate. I love it. Right? What was the conjugate again? 3 rad 5 plus 2 rad 3. And then you FOIL this out, FOIL it, FOIL, FOIL. Some of you guys seem to believe that somehow this times this becomes 1, which is neat. There's a lot of numbers happening and they just all become 1. No, no, no. That's a little, you just make it become what it's supposed to become. Why do we do this? So that the bottom becomes rational. There's no more radicals. The only place there could be radicals is the middle term, and the middle terms cancel. That's the idea there. What is I again by definition? I?
Imagine.
No, what is it equal to by definition? Square root of negative 1. So I is a radical, primarily. So how would you do? So I mean, blah, 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 blah. I'm not going to do that because that's shit we already know how to do. So now, if I had 2 minus I divided by 7 plus 3i, how would I do that?
Conjugate?
Yes, in fact, and now we call it the complex conjugate because it's a complex number. To be honest, it looks better, right? What is the conjugate of this?
7 minus 3?
Yes, 7 minus 3i. So you guys finish that out. That one will do since it's new.
It sort of looks better.
There we go. I was going to say, I love the people that just don't do it. Now's the time I want to do shit and do mistakes so I can figure out why they're mistakes and not do it when I actually get graded for it. Okay, so let's see. Just gotta put those understood parentheses in there and FOIL this sucker. So on the top I get 14 minus 6i minus 7i plus 3i squared. On the bottom I get 49 minus 21i plus 21i like we designed it minus 9i squared. And now we just simplify the top and the bottom. So this will be 14 minus 13i. What's this become? Yeah, I squared is negative 1 times 3, so negative 3. 49. These go away. And the I squared becomes -1 times -9 plus 9. So then on the top I get 11 minus 13i all over 58. Now that's fine. That's beautiful. I just want to show you, anytime you do something with complex numbers, the answer must be a complex number. And what's the form of a complex number? A plus bi. So if I did take one more step, this is fine, but if I did take one more step, I could see what A was, and I could see what B was. A plus bi. You have to do the next step? No, not really, but I just want to show you the answer is a complex number. It's in the form A plus bi. Yes?
So the one before this, that's just how you were solving the one before this? Or the section before this, but without the eyes?
Oh, this one?
Yeah.
Yeah, that was in the chapter before. That was on this last test.
So that's essentially,
Yeah, the conjugate, use the conjugate. And here you use the conjugate, we just call it the complex conjugate because it's got complex numbers. Same idea though. I is a radical, so it's going to act the same as other radicals in a lot of situations. Okay.
Are we ever going to have to write it like that? To be written out like that? No?
No.
Okay, good.
Well, if you're using my math lab, they might require you. Sometimes they want it in a certain form.
Okay. I was just talking about test-wise.
No.
Okay.
No. Okay. That was the last thing in section 10.8. So section 10.8 is huge. Some of you guys are like, well, it's just a bunch of I's running around. But I mean, it expands your knowledge of numbers. It's sort of like if you took all of algebra and you never heard anything about negative numbers. And then somebody said, you know about negative numbers? What the shit are you talking about? So everybody really should know these because they are a part of the numbers we created. They are. But we should all know them.
It's like telling someone the world is round.
Exactly. Blow their mind a little bit. What are you talking about? All right. Blah, 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 blah. So, we're going to get a little bit into chapter 11. We're probably going to call it an early day pretty soon. Yes?
So,
When I say soon, I mean relatively soon, not like 5 minutes. So don't get too excited.
for July 4th, what's the days that will be the intervals of break between,
You have the 4th off. That's it.
Okay, so,
Yeah.
We'll
They
see
should
you on
really
Monday.
give the next day off to recover. So you just have to recover quickly. After or whatever you're doing. I don't know. Maybe you don't have to recover.
Drink lots
Maybe
of water.
you do. Yeah.
it's gonna be hot. It's gonna be really hot.
Is Wednesday hot? I think it's supposed to be hot by the weekend. It's supposed to.
Yeah, it's supposed to be like 100 degrees by the weekend.
Exactly.
yeah,
Awful.
yeah, Friday and Saturday.
Living in the desert. Who knew this would happen? Huh?
So now I'm saying Friday and Saturday.
Oh yeah, yeah. All right. So chapter 11.
Yeah.
It's like living in Oklahoma. Don't we have tornadoes? What the hell's going on?
So we're not doing 10.9 or is there no 10.9?
Yeah, there's no 10.9.
Awesome.
Pretty sure there's no 10.9. If there is, we're not going to worry about it. We're approaching, some of you guys, obviously, a lot of you should know Quadratic Formula. We're finally going to officially know it, so you'll officially be able to use it. Before now, you can't use that shit because we don't officially know it. I like chapter 11, playing bankruptcy stuff. Let me give you this. We're going to kind of work off of this here. There's actually, let me see how I want to work this. No, I'm going to work this. Yeah, I guess I do want you to have both of those.
I've never seen such enthusiasm.
No, hold yours.
The Quadratic Formula.
So simple.
It's like easy.
Dude, in high school, I sucked at quadratic. I would always end up with something.
The last test that we took in math was so easy.
Yeah.
The final was awesome. It was all on Quadratic Formula. So
Alright, I'll keep it in open mind.
Probably not the right.
Yeah, that's true.
That's what you do. It's like if you
Yeah,
can.
I agree with that sentiment.
See, I thought our teacher last semester was awesome. She was good.
Kind of crazy.
I like crazy. Jeff's crazy. That's why I like Jeff.
Heck yeah.
If you go into that, you either are crazy in the beginning or it makes you crazy. Eventually. Well, again, it's grad school.
Oh, cousins.
What is this, Jeff? The white is an excellent.
Usually. All right, I don't feel like getting on there, so I'm just going to try to do this up here.
Oh, jeez.
So this is the main form of a quadratic. The really funny thing about the word quad normally means what? Quad. Four things, right? So, but the reason we call this quadratic is because a lot of it deals with multiplying the sides of squares, right? If I multiply, if this was x plus 1 and this is x minus 2, don't I get x squared, blah, blah, blah? So that's sort of where that comes from. The first people that studied this were actually looking at applications involving squares. So we call it quadratic because squares have 4 sides. Just in case that was in the back of your head, like, what the shit's wrong with these idiots? They're the ones that do geometry and they don't know their own words. Blah, blah, blah. So we know, you should know what this looks like when you graph it, right? Yeah, let's do the basic one. Y equals x squared. We shouldn't even really need to do a table of values. What's 0 squared? 0, that's amazing. What's 1 squared? 1. What's negative 1 squared? 1. 2 squared? 4. Negative 2 squared. So don't freak out. We do know complex numbers exist now, but it's definitely not in the realm of this class to graph complex numbers. That is quite a bit more to that, like I showed you. So don't freak out. We're not going to suddenly start graphing complex numbers. We will start allowing complex answers. So if I say now, what's the square root of negative 4, it's not good enough to say not real. I say, well, yeah, duh, tell me what the answer is. Right? What's the square root of negative 4?
2i.
2i. We know now. So here's that. We all know, we should know, these are nice parabolic. Why is it not linear? Because it's not to a first power. If all my variables were at most to a first power, that would be a straight line. Anything not a first power is going to be some kind of a curve. Here's your x square. So the one they give us is to look at is this guy, x squared plus 2x minus 3. And you can see from the graph, what are the x-intercepts? Just looking at the graph. Yeah, the intercepts are negative 3, 0, and 1, 0. You just see them from the graph. How do I get the answer algebraically? How do I get those intercepts algebraically? Don't plug them in, then they would come from nowhere. Where do they come from algebraically? What do x-intercepts mean? They are where y is. When do I hit the x-axis? When y is 0. Where's y here? Where's y? I love you guys. Yes, it is. What took the place of y? And we can bring it back anytime we want to. I'm bringing y back. F of x is y. Right? Doesn't that represent the output? So what do I make this to find the x-intercepts? I make this 0. How do I solve that? Don't say quadratic formula. We still haven't learned a damn thing, but it is coming. You just have to factor that thing. It's easy. How do I factor this? Negative 3 is only a 3 and 1. You just got to figure out which one is positive, which one's negative. Of course, which one's positive? The 3, the bigger one. So then I get x equals negative 3, 1, which we already knew from the graph. Can't graph them until you know them, though. Because obviously, this is old news. We know how to do this because we've dealt with polynomials before. We're just getting deeper into quadratics specifically in their graphs and how to deal with them and how to solve equations with them. Okay, I like it. Oh, so how many solutions does this have? How many real solutions does this have? Can you see the solution? I'm sorry, solution, Jeff. If I had this equation, how many solutions does it have? One. I like it. Now, to be honest, here's the funny thing. So the answer here is x going to be 0. 0 shows up twice, though, so there are still two numbers. You see that? Remember that fundamental theorem of algebra they were talking about? If I had an x to the 7th equation, there has to be 7 answers. Some of them could be real, some could be complex, and some of them could be repeated. So I could have the same number repeated 7 times, and that's my answer. What would the picture look like if I had 2 answers? What would the picture look like? 2 answers to f of x equals 0, where this is quadratic. Now, of course, that is the x-intercept. So what would have to be true for the graph if it had 2 answers for f of x equals 0? That would mean it has 2.
Rapidly? Or
There's only one function, so it can only be one parabola. That hits the x-axis once. If you were math god and you could reach in here and move this thing around, where would you move it so there were 2 places it hit the x-axis? No, just move it down. Would it hit twice then if I moved it down? Can you guys see that? If I moved it down, would it hit twice? Right? So if that was the situation, I don't know if you guys remember this, but how do I move a function down? I just subtract something from it. So if I had the equation, the function x squared minus 4, wouldn't that be this thing moved down 4 times? 4 places, right? So this would be negative 4 here. What would these be? Can you figure it out algebraically? What those would be? Do it. Take a minute. Don't say it. Find out what the answer would be for that equals 0. So this equals 0 is how you find the intercepts. We know how to do this. How do I do that? Factor. And how does it factor? So x is 2 and negative 2. I like it. Cool. Right? 2 from here, negative 2 from there. I like it. So that would be a situation where it has 2 x-intercepts. I like it. If I pull this thing up instead, how many real answers will that thing have? That's like what they were talking about on the thing. If I had x squared plus 1, it's going to lift this whole thing up by 1. Oh, shit. So let's talk about how to get the answer to this in a couple different ways. Let me do it the more direct way, and then I'll take us back and show you how you can actually factor that. Right here. Some of you guys like to do it a different way, but then you don't know the complete way to do it. If I were to add 4 to both sides, wouldn't this become this?
Yeah.
Now, if anything I do to an equation, it has to have the same answer at the end. That defines what's legal to do to an equation. It's got to have the same answers. That makes it an equivalent equation. So doing that shouldn't make there be just one answer, but a lot of you guys do this, and you say x is 2, yay, I'm done, but no. What answer did you lose?
Negative 2.
Yes. So if you do it this way, you have to put a plus or minus there. When you take a square root, you better put a plus or minus. It's the equivalent of that question, what are the square roots of 900? Remember that question in the homework? Positive 30 and negative 30. Those are the 2 square roots of 900. So this is saying, what do I square to get 4? 2 things, positive 2, negative 2. I can see them here. I got to remember both of them here. So how would I solve this thing equal to 0? How would I solve that? I can subtract 1. Is that cool? Then I can take what? To get x by itself, I can take a How do I kill the square? Take a square root. The minute I put square root down, I better put a
Plus or minus.
plus or minus. And what is the square root of negative 1? I. That's why they don't show up on my real graph. I didn't graph any complex shit, and the answer is complex. That's why they don't show up here. That's the whole thing where he picked it up, and he's like, oh, look at that. Okay. So that's one way to solve a quadratic. When it's only an x squared piece, I can solve it relatively easily. So let me give you a couple more. I'm getting a little ahead of myself, aren't you? It doesn't matter.
So as long as that one's positive, like plus something, it'll end up as an I.
Beautiful. So remember, we could not factor, yeah, before I forget, remember this was, I can't factor this before? Now it's not good enough. We can factor it now. We know the right numbers now. The square root of x is x. Square root of negative 1 plus 1 would be x squared minus negative 1. Right? I love you guys. Why is x squared minus 1? Why is that easy to do? Because what do I multiply, make negative 1, and kills itself? Would cancel would be positive 1 and negative 1. They do that. So I need a positive and a negative. But now if I put plus 1 minus 1, it's not going to multiply be positive 1. But what if I put plus I minus I? What's I times negative I? Negative I squared. What's that?
1.
Yeah, I squared is negative 1. Negative that is 1. There, we got something that when I multiply it by itself, it comes out negative. So this is now possible. So how would I factor? Let me see if you guys get this. So I can factor x squared plus 1 is x plus I, x minus I. How would I factor? Again, I should probably not use Roman numerals. How would I factor x squared plus 9?
Plus 3I minus 3. X minus 3.
Yeah, I. All right. If it wasn't an I, why would that be completely wrong? Because 3 times negative 3 is not positive 9. Putting the I in there makes it negative, so it changes the sign. So it makes it possible.
So you need it on both of them?
Yeah, if you only put it on one, you'll get 3ix minus 3x. Those are not like terms. You don't even kill the middle term. They have to be the exact same terms, different signs in the middle. Yeah. It's got to be there.
So, do you write it like that, plus or minus 3I, or just...
What's happening? If I said factor this, that's the answer. But that's it. Right? Right? If I said factor this,
When
that's
did
the
you
answer.
do that plus or minus thing that
You ready? If I said instead solve, now we could either do it that way, the way I was doing earlier, and you can subtract 9, right? Right? Take a square root. Oh, plus or minus, oh shit. If you take a square root, you better put the plus or minus so you don't forget the negative root. And what's the square root of negative 9? 3i. So I can see now if I use this way instead, so that's beautiful. Nothing wrong with that at all. But if I factor this thing, don't I get the same answers? I get negative 3i, positive 3i, plus or minus 3i. Okay.
So you had to have a plus 3 and a minus 3, plus 3i and minus 3i to get the positive 9
Because I need an I squared. So that the negative 9 that I would normally have gotten times I squared is negative 1. So negative 9 times negative 1 is plus 9. That's why it's plus now.
How would you differentiate that from the regular factoring where...
Because there would have been a minus there. That would have been a difference of squares, which is totally real.
Okay.
Sum of squares, we used to have to say it's prime, but now we go, oh, now I know enough numbers to do this. We didn't know the numbers we needed. And if I would have told you then, you just don't know enough numbers, you would have looked at me like I was insane. But now you're like, yeah, you were right.
So the main difference is that it's addition to subtraction?
Yes, yes, and I really, why is this so damn easy? Because what do I multiply by itself to get 1, negative 1? That also cancels with itself. 1 and negative 1, right? Here, what do I multiply to get 9? Well, to get positive 9, it'd have to both be positive 3 or both be negative 3, and that wouldn't work. They wouldn't cancel then. So the I comes in and says, okay, you can still be opposite signs. I'll help you out at the end. I'll make it become a plus so it all works out. Okay. Now let me ask you, I can't remember now if I've asked you this kind of question before. If my answers to this kind of a problem were 7 and negative 2, can you tell me what the equation was? Here's the answers. The equation looked like this. Here's the answers. What was the equation? Some of you guys are always like, how the shit would I know? Because where the hell would 7 have come from? What would it look like altogether? X minus 7. X plus 2. So what have I told you the answers? Is that cool? Somebody had a hand up, but I don't know if I answered your question along the way. Are you guys good with it? And then I could FOIL this out and get like the whole, that form. So what if I told you the answers were 3i and negative 3i?
X squared plus 1.
Yeah, x minus 3i, x plus 3i equals 0. Right? Didn't we already know the answer to this equation, x squared plus 9 equals 0? Didn't we already know it was 3i and negative 3i? Therefore, it has to factor like this. It has to, because those are the answers. So the fact that it factors like that should not be a big surprise, because we already had another way to figure out what the hell the answers were. So if I know those are the answers, this is what it is. And if I multiply this out, middle terms cancel. Negative 3 times 3 is negative 9. I squared is negative 1, becomes plus 9. Bam. Right? Okay. So here, factor this. I love how some of you guys are like, you can't make me do anything. You're right, I can't. I just bear the bad news. So what do you get?
X plus 9i and x minus 9i.
I love it. You only have to factor this if I ask you to be honest. If I said solve this, I would hope you guys would just solve it directly. Let's do a couple, and then there's some I want you to try on your own. How would you solve x squared equals, let me give you one that's a little bit different. Negative 11. What would you do? Square root both sides. The minute you do that,
Plus or minus.
it's got to become second nature. Just it should feel wrong to not put that plus or minus there. The square root of x squared, I'll do that. What do you get over here? And the plus or minus takes into account the two possibilities there. It's already there. What's the square root of negative 1? I. And what's the square root of 11? I don't freaking know. There you go. That's it. I don't know what the square root of 11 is, so I'm just going to leave it square root of 11.
So you take the negative out the...
Yeah, because I could write this as plus or minus square root of negative 1 times square root of 11. Is that cool?
Oh, gotcha.
So it's just plus or minus I root 11. We normally put the I in front, so it doesn't look like it's inside the square root. Can you think for a second about the square root of I? Now stop thinking about it. Don't write that down, right? That's I. Take the I out. Ooh, that sounds horrible. Put the I out front. So it doesn't look like it's in the square root. That would be horrible. I love you guys.
Does it
Oh.
matter if the plus or minus is after I?
Oh, yeah, okay, I'm glad. So this is the correct answer to that. How is this different? This is not the correct answer. Are these different though?
Yes.
Or is this just Jeff going, the format's different? Meh.
It's different.
These are completely different. This is I times rad 11, both positive and negative. This is I plus rad 11 or I minus rad 11. Completely different. The main operation here is multiply. The main operation here is add, subtract. All right, I like it. So don't make that I jump over that plus minus shit. It ain't that strong. You can't do that. A little too high of a hurdle. All right, you guys on the back of this first sheet, on the back of the one that says section 11.1 there on the top, there's 5 problems there. At the very top. I want you to try those out. I'll give you a hint on number 4. If you're multiplying anything out on number 4, you're doing it wrong. Yeah, totally. Not until you take a square root.
Oh, just kidding. I got sorry.
You're the one that puts that down. So make sure you guys are on the right track for number 2. What do you have to do first for number 2?
Subtract 12.
Get what by itself? Why is number 1 easy? Because x squared
By
is
itself.
by itself. All the numbers are on the other side. I can do the square root, no problem. So what should I do with number 2 first?
Subtract 12.
Get x squared by itself. Subtract 12. Yeah, keep going. All right. Yeah. So the idea of getting the term that has x in it by itself first. It's always a part of this. And you can do this root of 4, and you get the negative inside too. You can do that.
You said we're multiplying for number 4, we're doing it wrong?
Yep.
4, 2.
negative 4 before it takes square root.
Oh.
Get the x squared piece by itself.
Gotcha.
Very first step is get the x term by itself, but then to divide by negative 4.
I'm gonna do this one right?
Yeah, beautiful.
Okay, so I just said I did this one wrong.
Yeah, see how that one is just like that one.
No, I'm gonna do that.
Why'd you do this? Because then you can free up the x, because if you kill a square, you're taking a square root. Didn't you do the same thing here? The square root? Want to kill that square?
Okay.
Yeah. So 5, you make it look like this. You do the same thing here. All right, let's see. Those last two are a little bit tricky. This one shouldn't be. Square root, plus or minus. So you get x is plus or minus
5.
5. All right, I like it. Here, you gotta subtract 12 and then divide by negative 4. You get 3. I love when people try to do more than you can. What do you do to both sides? Square root,
Plus or minus.
plus or minus. So it's plus or minus rad 3, because I don't know what this shit rad 3 is. So if you can't do it, and you can't break it down, then don't do it. I mean, it's beautiful. You gotta like that. And then this one's nice. It actually does become something you can do something with. You get negative 20 divided by 5 is negative 4. Square root,
Plus or minus.
square root of negative 1 is I. Square root of 4 is 2, so you get plus or minus 2I. Is that all right?
The only reason that I got that same answer, but for the previous problem we did on the board, we had x squared equals negative 11. The only reason that I came out before that was because 11 couldn't be squared.
Yeah, exactly.
Okay.
There's a square root symbol, so I put the I in front, so it doesn't look like it's underneath the radical. Here, the radical went away, so I put the number out front like we normally do.
Okay.
Yeah.
So what was the logic for putting the I there for number 3?
Because I don't have the square root of 4. I have the square root of negative 4, which is square root of negative 1 times the square root of 4. Negative 1 square root is I, square root of 4 is 2. Yeah, I like it. So please let that be relatively simple. What's the square root of 81? So what's the square root of negative 81? 9I. If there's a negative in the radical, there's going to be an I in your answer. That's it. Because that's the square root of negative 1 is I. So that's the negative 1 factor. Taking care of what's putting the I down.
I have something on topic, but kind of stretch. Are we going to be using the I with like 3 to the third root? So like odd roots?
Yeah, of course. Yeah. I mean, I'd have to give you the problem like, what's I to the 17th? Like we were saying earlier, you could just divide by 4, see what the remainder is, and figure out what the answer is. That's why I said you have to memorize. I to the first is I squared is negative 1, I cubed is negative I to the fourth is 1. Kind of restarts after that. It's something we call a cyclic process. It's a cycle to it. It goes through the cycle, starts over. So the cycle starts over. Goes the cycle, starts over. That's why I just care about the remainder. I don't care about how many times did it turn around. I just care about what position did it stop at. That's the remainder. What about number 4 then? Number 4 is exactly the same as number 1. They're exactly the same.
Square?
Square root, yep. I don't square anything, right? I don't multiply shit out. I square root. Then they kill the square. So you get x minus 4 equals plus or minus 7. Add 4, I get x equals 4 plus or minus 7. Don't just stop there. I love the student. This actually happened. Somebody came up and said, where's my plus or minus button on my calculator? I don't see that shit, Jeff. Holy shit. Okay. What are my two answers? 4 plus 7 or 4 minus 7? That's plus or minus. That's what that symbol means. You add them, So you get one answer, you subtract them and get the other answer. So my answers are 11 or negative. So compare this to that one. Now watch. Some of you guys started doing this. X squared minus 8x plus 16 equals 49. Subtract 49. Got to factor it. Oh, that's a bunch of shit. This is much quicker, would you not say? All right. Paying any attention, you would say, yes, that's quicker. So here, instead of subtracting 12 and trying to factor this shit, I noticed that this is a perfect square. Because what times what is 25? So 5 squared is 25, and 5 doubled is 10. Why is that 5 doubled important? Because if it was going to be x minus 5 squared, see that makes 25? That means the middle term better be negative 5, it should be double this. If I FOIL out x minus 5, don't I get negative 5x, 2 negative 5s, negative 10. So if the last thing is a number squared, and the middle thing is that number doubled, I can do this. And why is this so nice? Because now I can do like I did in number 4.
Oh, in example 5, it's x squared plus 10.
Is it plus? Oh, scheiße. So what's going to change here?
It's gonna be a plus right there.
There you go. I like it. And then what do I do? Just like I did in number 4?
Square.
Square root.
Radical root.
Plus or minus, thank you. It's going to go crazy. Boop. Plus or minus, and rad 12 you can break up. Whenever you can, you have to. Again, it's just like telling me the answer is 8/16. Like, no, it ain't. You got that one more step. So here's rad 12. Don't stop there, because rad 12 has a 4 in it. So you can do something more. So I got x plus 5 equals plus or minus 2 rad 3. And the last thing I got to do is to get x by itself, subtract 5. And I tell people, force it in there in front. That looks a little more natural. Negative 5, give or take, 2 rad 3. Yes?
And that's when it's like in front of mouth.
Yeah, totally, because you're subtracting 5 from both sides. So you can either write it as plus or minus 2 rad 3 minus 5. But it's a little more preferred to write it like this, with a plus or minus in the middle. I'm not multiplying both sides by.
With the 2.
What do you mean? Sorry.
Is it like when it's in the little pouch of the...
Oh, no. This is a 2 coefficient. It's not a 2 up here. It's a 2 down there. It's a 2 coefficient. Of course it is, because square root of 4 is 2. Yeah. Okay. All right, so one more idea, I think, for today, and then we'll head out a decent amount early. So this idea is exactly related to what I was trying to make the point of with the 5 and the 5 making 10 and so forth. If I had this, what would have to be here so that it will factor like something squared? Like, why did this work? If there's a 10 there, there has to be a 25 there. Because to make a 10, it's 5 and 5. And 5 times 5 is 25. So what number would have to be here so it would work the same way?
9.
Not 36.
9.
9. Why 9? Half of 6 is 3, squared is 9. And now it would factor like that, wouldn't it? In fact, here, you guys do this. Figure out what x plus 7 squared is. What's that? Figure out what x minus 9 squared is. Take a minute and do that real quick. See, really see this happening. So you really see why this works. So a lot of the time in math, we do something one way, and we try to see if there's a pattern to what's going to happen always, so then I can go backwards really easy. That's where factoring methods come from. So what do you get for this first guy?
Square plus 49
Yeah, because it'll be 7, 7.
plus 49.
So 49 is 7 squared, because that L in FOIL is the last. 7 times 7 is 48. You're like, wow, Jeff, it's amazing. 7 times 7. And 14 is double 7. What do you get for this guy?
Square minus 8 squared.
81 is 9 squared, and 18 is 9 doubled. So let me try it again. So if I had x squared minus 12x, what would have to go here so that it will factor like something squared?
36.
Yeah. So the first step is cut this thing in half. And the second step is take that and square it. That's called completing the square. I'm putting here what has to happen for this to be a square. That's why I call it completing the square. So what would have to be here? Plus 36. And then how would it factor? X minus 6. That's awesome. Is this true? Yeah, if you FOIL this out, you get minus 6x, minus 6x, minus 12x. And negative 6 times negative 6 is plus 36.
So is that like a shortcut?
It's a beautiful method. So here's what we use it for. Let me just do this. Let me start off the way it was going to look. Yeah, I like it. That's nice and gross. Do we know quadratic formula yet? Have we talked about it yet officially in this class? No. So nobody tell me negative b plus. No, screw that. The only way we have to solve this is to factor it. Can I factor this? What factors of 1 had to be 8? Well, that's not going to happen. So what I do is I make some room. And I try to figure out what would I add to both sides so that this becomes something squared, because then I can just take a square root of both sides. I can do it like we did number 5 on the examples. So that's an 8. What's the first step to figure out what has to go here? Cut that in half to see what the number would be that goes here. So that's kind of funny. The first step tells me what the factored form will be. And then how do I figure out what has to be added here is to take this and square it to see what has to go here. Negative 4 squared, 16. Again, why? Because whatever goes here is going to multiply by itself to become that last number. Yes?
Say the 8, what if it couldn't be half?
Say again?
Like, what if you can half the 8? What if you just...
Oh yeah, we're going to do some uglier numbers in a minute, but I just wanted the idea out there. And then the beautiful thing about this process is I can make that number as ugly as I want to. Process don't give a shit, and neither should you. We'll see. We will get fractions, but who cares? We'll see what I mean by that in a minute. So what do I add here? 16. And if I add it here, I better... That's the biggest mistake, is people forget to do that, because they're like, why would that side doesn't need it? And it's like, that side doesn't get a choice. It happened to this side, it has to happen to that side. Period. I don't care what that side needs. It's going to get that shit. So 1 plus 16, 17. And then what can I do to solve this? Now that I put it in this form, square root. Better put plus or minus. X minus 4 is plus or minus rad 17. And the last step is just to add 4. It's almost too nice to believe. So the key things here are the 2 steps. Yes?
Well, if you're factoring it to get x minus 4 squared, why do you have to subtract the 16?
Add the 16.
Well, add, yeah.
Because otherwise, it doesn't become this. If I FOIL x minus 4, I don't just get x squared minus 8x. I get x squared minus 8x plus 16.
don't get why you put it on the other side of the equation.
I can't add something to one side without doing it to the other side also, period. Right? I can't change one side without changing the other side, or else the equality doesn't work anymore. Is that cool? So really, it's like 3 minus 2, is that 1?
Yeah.
Yes. If I add 16 to this side, is it still... No, I better do this. Oh, now it's true. 3 minus 2 plus 16 is 1 plus 16 all day long. That's all we're doing. I like it. So why did we add 16 here? Because of this process. The equation doesn't give a shit why you did it. It says, I'm an equation, you better do it to both sides. I like it. That's just a rule just to keep the equality true. If you don't do it to both sides, you made an entirely different equation. Let's do another. We do one more with a nice number in it. So what's the first step?
Add 5.
Good. Make some room. Get that 5. Real quick, though, the first step really is noticing you can't factor this damn thing. And you go, oh, shit. Add the 5. So I made some room. The first step is just to figure out what this is related to. And the second step is to figure out what would go here from this. So it's kind of backwards. The first step tells you how it's going to factor, and the second step tells you what you put here to make it factor like that. So what's the first step?
So divide by 2.
Yeah.
14 by 2.
The middle dude, 14 divided by 2 is 7. That's what's going to go in here. That's what kicks ass about it. I don't have to think about factoring. I know how it's going to factor because that first step. And the second step,
Square it
square what I just got, and that's what I have to put
on both sides.
on both sides. If I add 49 to this side, I better frickin' add 49 to that side. So I get x plus 7 squared equals
54.
54. Because isn't x plus 7 squared, isn't it?